Okay, go ahead and look at number one. The first part of this is gonna be really similar to what we did last time. We're gonna add a little bit to it, but it's very similar. So if you're looking at that first question on here. What do you think that you should do first? Add one is correct, very good. So we're gonna plus one to both sides, which means our 3 is now what? It is now a 4. So 8 sine theta equals 4. Okay, then next step,
Divide by 8.
divide the 8 out of the front, very good. So now you have sine theta equals, and if I look for 4/8 on the circle, I'm not gonna see it written like that. What's that the same as? Okay, very good. Okay, from here, I'm gonna look at my circle. And if it's a sine theta question, should I be looking at the x value or the y value? Sine is the y value, and if I want my y value to be positive a half, what section of the circle can I focus on? The top half, because a positive y value would only be up here. Anything down here would be negative. So where is a half a positive y value? And we're gonna do degrees today. I see a half here. How many degrees is this one? Okay, 30 on this side, 150 on the other side. Very good. So write down theta equals 30 degrees and 150 degrees. Oh, oops, I meant to write that in this blank, but it's fine. Okay, so we got 2 answers. Now, what we're gonna do is we're gonna bring in a little bit of what you should have learned when you were still in the video mode and I was gone. But it's okay if you didn't really learn it that much. We're just gonna kind of skim over it. So what we're gonna do is we're gonna do a quick sketch and solve by graphing method. Now, graphing method, you're gonna take each half of the original equation, graph them, and then look for where they intersect. That's what graphing method is. So the first half of my equation was 8 sine theta minus 1. And the second half of the equation was 3. So I'm basically taking that full equation, I'm gonna graph each side of it and then look for the intersection. So I'll go ahead and put find intersection. That's what graphing method is. So the easier of those 2 equations would just be y equals 3. Because y equals 3 is a constant. So what would that graph look like? Yeah, straight across, right? So go, you're right. So go to 1, 2, 3. And then draw y equals 3. Okay, so that's a horizontal line through the number 3. And then on the other side, we're gonna need to graph 8 sine theta minus 1. That is something you learned when Miss Nixon was teaching your class, but we're gonna just kind of go back over it a little bit. Do you see on the board over there? Cosine is blue and sine is yellow, and they're both wavy patterns, yeah? You remember doing a graphing unit on those? What do you think the minus 1 does to where the wave is? Does it move it up or down? Minus 1. It's gonna move it down 1. So instead of my wave being centered on the x-axis, I'm gonna make an axis that's down 1 from there. Okay, the second thing you should kind of sort of remember is that the 8 in the front controls how high the wave goes. So normally your wave is pretty short, but an 8 is gonna make your wave go way up and then way down, and then way up, and then way down, and then way up, etc. So that is about what this top equation looks like. You should have done it in much greater detail when you were doing those notes, but for today, that's good enough. Okay, so this is the sine x. This is y equals 3. Do you see where they cross? Do you see where they cross? How many times did they cross? Did they cross only twice? No. Now, the first two cross points we found, this one is 30 degrees. And this one is 150 degrees. Okay, but the problem is that because your sine wave goes on forever and ever and ever and ever, really, there aren't just two answers, because every time the wave repeats itself, you're gonna get another two answers and then another two answers. So the term for how often it repeats is called the period. And the period is gonna be one full wave up and then one full wave down. So I'm gonna highlight it in purple. This is one period, up, down, and then back to the center. Okay, that's one full period. Does anyone happen to remember how many degrees it takes to get through one full cycle? Anyone?
180.
Not 100, it is 360. Okay, and here's why I want you to think about the circle. One full circle is one full period for the normal sine and cosine functions. Okay, so if I want to find the next intersection, I can just add 360 and then I'll know what that number is. So come down here to where it says complete solution. We're gonna write theta equals 30 degrees plus 360. And what that means is that the first one is 300, but then every 360 degrees, I'll get another one and then another one and then another one. Okay, not just 30, but also where else? Wasn't it 150?
Yes.
And then that one is also gonna repeat every 360 degrees. So that would be your complete solution, which means not just the first two answers, but that's how you could find any of the other answers because they go on and on. Okay? Let's look at number 2 right next to it. So we did one sine, we'll do one cosine. What do you think we should do first on number 2? Okay, subtracts the 5. Very good, that's right. So we're gonna minus 5 across to the 4 side. What's 5 take away 4? -1. So I have √2 cosine theta equals -1. Next step, I have a number in front of my cosine. It is multiplied. How do I undo multiply √2?
Division.
Okay, divide √2, very good. And then if I look on my circle for cosine theta equal to -1 over √2, I'm never gonna find that because of what rule?
It came down.
No roots on the bottom, which means I'm gonna have to fix it. √2, which means that my new thing I'm looking for on my circle is what fraction over here? Negative in the front. √2 on top, and what on bottom?
2.
Regular 2, very good. Okay, this is a cosine question. So on my circle, should I be looking for this number as an X or a Y? Okay, this is gonna be an X value. And then I'm gonna go back and write over here for sine, we were looking for a Y value.
Where did the 1 go?
The 1 is still there, you just usually wouldn't write it. It's kind of like X versus 1X. Okay, so look on your circle. Where are your X's equal to negative numbers? The front half of the circle or the back half? Negatives would be on the left side, so I'm gonna put that up here. Where is my X a negative √2 over 2? Okay, 135, and then also 225 right here. So put theta equals 135 and 225. Okay, then we're gonna do a quick sketch, okay, of what a cosine graph looks like, just to kind of make sure that you remember. So take your original equation and cut it in half. We're gonna have √2 cosine theta plus 5. And we're gonna have y equals 4. √2 cosine theta plus 5 and y equals 4. Which of those is gonna be really easy to graph?
4.
Y equals 4. Nice flat line. Count up 1, 2, 3, 4. That's our constant. So then the question is, how do we graph the root 2 cosine theta plus 5? Okay, if you look back over at the board over there, cosine is the blue parent graph. You'll notice that it's still a wave, but the cosine wave, you start at the top, you go way down low and then way back up. But it's the same thing. So what do you think the plus 5 at the back does?
Like, up.
Up 5. So if this is 4, 5 would be right here. Do a dotted line to represent the center of the wave. And then remember what I said, cosine should start at the top. You're gonna do a really deep plunge and then come back up. So I'm gonna start up here, deep plunge, back up. Deep plunge, back up. Deep plunge, back up. Okay, obviously this is a sketch, it doesn't have to be perfect. So you should start at the top, go down and then up. Down and then up, down and then up. We found the first 2 intersections. The first one occurred at 135 degrees. And the second one occurred at 225 degrees. But we're observing the exact same pattern, that these are not the only 2 answers, because every time that I complete another cycle, I'm gonna get 2 more answers and then 2 more answers and then 2 more answers. So to fix that, we're gonna add the period n. What is the period for cosine? Do you remember? Remember the period for cosine? It's the same. So it's still 360. So it's gonna be theta equals 135 plus 360n and 225 plus 360. Okay,
I'm seeing. Well, see, good, yeah, good.
all right, is that easy enough? You get the idea? Okay, we're gonna do one more of that type and then we're gonna go on to the second type and then we'll be finished. So go ahead and turn the page. Your homework's on Dell's math. Like 8 questions. Okay, we're gonna do we'll do number 4. Okay, what do you think you should do first? We're gonna do 4. Subtract 5. So 6 minus 5 is gonna give me a 1. Okay, then we gotta get rid of the 2 in the front. How do we do that? Okay, divide by 2. So now it's gonna be cosine theta minus 20 equals a half. Okay, from here, do you think I can add that 20 to get rid of it?
Yeah, no,
No.
it's in parentheses.
Because it's in parentheses, that means we need to wait. We have to follow order of operations. So the next thing I need to get rid of is cosine. And how do we usually get rid of cosine? We look for what on the circle? X or Y?
Why?
Cosine is X. So will you find the 2 places on the circle where your X value is a half and tell me what they are? 60 and where else? 300, very good. Now, that's gonna cross out the cosine. But then we're left with theta minus 20 equals 60. And theta minus 20 equals 300. So once you look at the circle, it's gonna cross out the cosine part. But this entire middle here has to stay all the way until you're finished solving. So we picked 60 and 300, but those are equal to theta minus 20. How do we find our final answers? Add the 20 across.
Oh, I'm sorry, that's equals.
Yes. So we're gonna just add the 20 across. So instead of my final answer being 60, what's it gonna be? 80. And then for my second one, I got 300 off the circle, but since I have to add 20 to it,
320.
it's gonna be 320. Now remember, those are only the first 2 answers. Every time that your graph goes through a full cycle, I'm gonna get another one. So I add 360N to both answers. That's called your complete solution or your general solution. Okay, overall, did that make sense? Pretty easy? Okay. We do have to cover one more type, so if you'll go down to this little bottom part here. Okay, this is another maternity leave moment, let's see what you remember. So the number at the back, how did we say that number shifts your graph?
Forward.
Up or
Down.
down? So I want you to put an arrow, and you should kind of remember all the functions, even if their shape is different, they follow the same pattern. So this is gonna be your shift up or down. What number shifts it left or right? The one in the parentheses, very good, which in this case would be the C. So underline your C. This number is gonna shift your graph left or right. And do you remember anything weird about that number? Good. If it's negative, you go to the right, positive, you go to the left. So I'm gonna put a little star here and put opposite sign. Why is that number an opposite sign? Because it's inside what? Parentheses, very good. Okay, the number at the very front, your A, that number is gonna control your vertical stretch or compression. And so when we're doing sine and cosine graphs, that's gonna control the height of the wave. Does anyone remember the word for how tall the wave is? Starts with an A. Amplitude, very good. So I'm gonna put here, this controls the amplitude, which is how tall the wave is. So your standard sine or cosine graph only goes up to 1, down to -1, up to 1, down to -1. But if you put a different number in that spot, it'll stretch your wave to be taller. So the last number that we have to talk about is the one that's important for today. It's the letter B. And B is gonna control the horizontal stretch or compression. And the reason that this number matters is that a horizontal stretch or compression is gonna control the period of how long it takes to get through one full cycle, which is how long for the parent graphs?
360.
360, very good. Okay, so I want you to very quickly look at these bottom 3 questions. I'm gonna make sure you remember this from when I was gone. What number in this is the B? In the B position, that's the only one we care about,
12.
the 12. Okay, because that number is in parentheses, you're gonna do the reverse effect on 360. So see how they put it times 12 here? Then the new period is gonna be 360 divided by that number. So if they say to times by 12, because it's in parentheses, I'm really gonna divide by 12. Use your calculator, please. What is 360 divided by 12? $360 divided by 12? Okay, 30 degrees. Now, quick question, if your original period was 360 and now it's only 30, is that a stretch or a compression? Very good, so I want you to write, this is a horizontal compression. Because the period got shorter for that one. Okay, let's take a look at letter B. Which number in the second equation is in the B position in the equation? 1/4 means divide by 4. How will I find the new period? Multiply by 4. So the original length is 360, but I have to multiply by 4 because since it's in parentheses, it always has the reverse effect. So what is in your calculator? 360 times 4. 360 times 4. 1440. Okay, and now do you imagine that would be a horizontal stretch or horizontal compression? Stretch, because it went from 360 now to being over 1,000, right? So I'm gonna put horizontal stretch. Is this looking familiar? Do you remember doing this?
No.
Okay. Okay, if there's already a fraction in the B spot, just flip it. So in this case, they say to times by 2/3, then what am I really gonna times by? 3/2. Do that in the calculator, please. New period is 360 times 3/2. It is 500 something. 5 what?
He said 540.
Oh, it is 540. Wow, are you doing it in your head? Wow, good job.
You got the last two wrong.
I thought you got the 14 one right.
No, I was 20 out.
Oh. Would that be a stretch or a compression, 540? Stretch. Okay, good. All right, so let's talk about why that matters. We did 3 little quick ones and then we'll just solve 2 more. Turn the page, look at the top question. What do you think we should do first?
Goodbye.
Okay, so we're gonna do both of those, but first we're gonna subtract. But we will divide eventually, so good job, that's okay. So I'm gonna minus the √3 across. So I have 2 sine 10 theta plus 11 equals negative √3. Okay, then after we subtract, we're gonna divide. So get that 2 out of the way. So I have sine parentheses 10 theta plus 11 equals negative √3/2. Okay, and then it's, and then as soon as you get to sine or cosine, that's where you're gonna look at your circle. So I want sine, am I looking for an X or Y? Sine is Y, and where are your Y values gonna equal negative numbers? What half of the circle? The bottom half, very good. Can you tell me the 2 places that your Y value is a negative √3/2? Okay, 240 and where? 300, very good. Okay, because that's where my Y values are negative √3/2. So I'm gonna put 240 here. And 300 here. But then remember, that only crosses out the sine part. You still have to keep this crap and keep solving.
Why does it like cross it out?
I'm just crossing out because really you're doing an inverse sign and I'm just not writing it. You know, the sine's the -1. So that's technically what you're doing on both sides. But since we're doing it with the unit circle instead of the calculator,
So you don't like need to put out the.
you don't have to put it, but that is what you're doing to get rid of it.
Yeah.
So then I'm gonna keep all that middle stuff equal to those 2 values. So 10 theta plus 11 equal to 240. And 10 theta plus 11 equal to 300. Okay, what would we do with the 10? Okay, you could distribute it, but let's not. How can we get rid of a times 10? Let's just divide it out of the way. Distributing isn't wrong, but it'll be an extra step later. So divide the 10. Now I have theta plus 11 equals what?
24.
24, because when you divide by 10, you just knock a 0 off. And then minus the 11 across, what do we get? Theta equals what? 13. Okay, let's go over to our 300 side, because remember, we got 2 different equations to solve. Our steps are gonna be identical. Divide the 10 out of the way. What's 300 divided by 10?
30.
30. So theta plus 11 equals 30, then do what? Subtract the 11, 30 take away 11 is how many? 19, very good. Okay, now from here, normally you would put plus 360 and on both of those. However, if there's a number in the B spot, you have to change the period. So look back at your equation. Is there a number in the B spot? There is a times 10, and if there's a times 10, how do I find the new period?
Divide.
Very good, so I'm gonna put new period equals 360, and if they say to times by 10, we're really gonna divide by 10. Which means how long will this one take to go through a cycle? 36 degrees. So then for my complete solution, I'll do 13 plus 36n. And then 19 plus 36n. And then I forgot to ask, but if your period is now 36 degrees, was that a stretch or a compression horizontal? That would be a compression because it got shorter. How do we feel about that?
Good.
Not too bad? Last question we're doing, number 8, and then you have the rest of class to work. Number 8, what do you think we should do first? Add the 1. So I have -4 plus 1. What will the result of that be? Okay. So I have 1/3 theta minus 12. -4 plus 1's -3. Then divide the 6 over. So I have cosine 1/3 theta minus 12 equals, what is 3 over 6 the same as? 1/2. And then on my circle, am I looking for x's or y's? Cosine is x's, very good. So look on your circle for where the x value is gonna come out to be -1/2. 120 is correct, and where else? 240. So then I take this entire middle section, 1/3 theta minus 12. I'm gonna set it equal to 120 was my first answer. And then I'm gonna set it equal to 240 is my second answer. And remember, even though you're getting 2 branches for that equation, you're solving them in the exact same steps. 1/3 is a divide by 3. How do I undo a divide by 3? Let's times by 3. I'm gonna start on the 120 equation. What is 120 times 3?
360.
360. And so then if theta minus 12 is 360, what do I need to do? Add the 12 across. And what is 360 plus 12?
372.
372, very good. Now let's solve our second one. Steps to solve are the same. To get rid of 1/3, I'm gonna times by 3. And what is 240 times 3?
720.
720. And then last step to get rid of the minus 12. Add that across. So 720 plus 12 is gonna be 732. Now, those are the first 2 answers, but remember, these are gonna repeat over and over again. They'll repeat every 360 degrees if the period is not changed. Is there a number in the B position?
Yeah.
What number is it? 1/3 means divide by 3. What am I gonna do to find the new period? Multiply. So the new period is gonna be 360 multiplied by 3, which is how long? 1080, very good. Is that a stretch or a compression for that one? That'd be a horizontal stretch, very good. So now let's write your complete solution. You would say it's 372 degrees. Repeating every 1080 n. Okay, then for your practice, you'll put a comma, it'll open that second box. You'll put your second answer, 732 plus 1080. Feel like we can do that? Okay. Go ahead and pull out your Chromebooks, please. And then we're gonna do the first two together just to make sure you remember the shifting stuff before you solve. So go ahead and pull up your Delta Math. And we're gonna do 2A. 2A and 2B. We need a scratch paper over here.
It's mid Oregon. Isn't that so? I think he's there right now. Oh, I know. I think oh, defense.
Alright, we're looking at 2A and then 2B. Okay, first question on 2B. What number is gonna shift the graph left or right in that equation? So left and right should be with the X in parentheses. So it'll be the 100. They put minus 100, which way are we gonna really move?
Left.
Right. To the right. So it's gotta be right 100 or right 100. Okay, then the last question is if we're gonna shift it up or down. Now you could cheat and put this in Desmos. Okay, but don't do that. Okay, which number normally is added to the back, but they just put it in a weird spot? The 4 in the front is the same as a +4 in the back. Okay, sometimes they'll kind of sneak it into the front, but it does the same thing. So if there's a +4, are we going up or down? Up 4, that means you're choosing which answer?
A.
A is correct. Very good. Go on to 2B. So number 1 should be A, or sorry, 2A should be A. And then we're going to question B. Yeah, so you should be on this one, y'all. 2A was A, and now we're going on to 2B. Okay, and it says to find the new period. So what number is in the period position?
3/2.
3/2. Do I multiply it by 3/2? No, reverse effect. What do I multiply it by? 2/3. And then if you multiply that, you should be able to find what number to put here.
120.
Okay, very good.
The number-
Okay, oh, that's not it? What is it? You silly goose. Okay, it should be 240.
No.
Okay, then from there on, you should be solving. If you need help, raise your hand. Okay. You always are doing the reverse effect, correct? So if it had, on the notes, it started off as a 2/3, so we timed by 3/2. But now if it's starting off as a 3/2, you have to multiply by 2/3. Or if it was a times 4, you'd really divide by 4. You know what I mean? Okay.